today we'll be finish 4-3 solving, and then your homework is going to be to finish the 4-3 homework evens or odds. We'll do review in class tomorrow. We'll also go over your quiz and see how you did on that, and then your test will be virtual on the following day. So what I like to do when I have two trig functions in one equation is to pull those out as different variables and work with it as an equation with variables as opposed to an equation with these trig functions, which can get a little intimidating when you see them. So because I have sine and cosine here, I'm going to call x cosine, because just to kind of keep consistent with how it is on our when we're working with it, cosine is in the x position, y is in the sine position. Remember though, you can use any variable you want. It doesn't really matter how you do that, what you put in those spots. But I'm going to replace anywhere I see a sine with y, and anywhere I see a cosine with x. And then I need to get everything on the same side of the equation. So I'm going to move the 2y over. So 0 equals negative 2yx minus y, 1y. And then I need to factor out anything that they share. I have two terms. I have negative 2yx as one term and y standing alone as another term. And so I will factor a y out of both of those. In fact, I'm going to factor out a negative y, because then that'll leave me with positive 2x plus 1. You could have just done regular y. That doesn't matter. I just wanted to do a negative y because to me, I like to get rid of those double negatives. So then I'll set my two equations. So negative y equals 0. That's my first factor. And 2x plus 1 equals 0. Well, the first one is when y is 0. Divide by negative 1 on both sides. And then the next one, I'll subtract 1 and divide by 2. And then I want to go up and finish solving this. Keep in mind that at this point I need to plug back in the cosine and the sine. So I'm trying to figure out when the sine is 0 and when the cosine is negative 1/2. Well, the sine is 0 at those two spots. So that's at 0 pi and pi. And the cosine is negative 1/2. Well, it's 1/2 in the pi over 3 family. It's negative in the second and the third quadrant. So that's 2 pi over 3 and 4 pi over 3. This kind of stuff shouldn't be new to you. So we're just solving these equations, and we're solving from 0 to 2 pi. We're following the latest directions that we had. Before we end today, we're going to go back to all solutions just to kind of take a look again at what that is so we don't forget how that works. But I wanted to get us sort of into the swing of things and point out a few things that are going to happen. And so the first thing, like you see that I have two trig functions in one equation, pull them out, call them different variables. In problem number 9, I have just cosine, but it sort of looks weird. It's cosine squared. So I'm going to start by, again, replacing this with an x, and then I'll solve. I could factor this. It's a difference of squares, but because there's no single x term, I can also solve it by adding 1 to both sides, dividing by 4, and then taking the square root of both sides to get my final answer. But when you do that, do not forget the plus minus when you take the square root. So that's plus or minus 1/2 is x. I took the square root of 1, got 1, square root of 4, got 2, took the square root of both sides, make that plus minus. I'm going to tell you right now that there's going to be, at least half of you are going to forget to put the plus minus, and you're going to lose half of your solutions. So when we have that, when you take a square root on both sides, you do not want to forget that it's a plus minus option. All right. So I have cosine theta equals positive 1/2 and cosine theta equals negative 1/2. Well, theta is 1/2 in the pi over 3 and 7 pi over 3. Nope, 5 pi over 3. Sorry about that. Oopsies. 5 pi over 3. And then for negative 1/2, that's 2 pi over 3 and 4 pi over 3. So I had to list, basically, it's all the way around the unit circle. Okay, so now we're going to go back. We're going to finish today with solving for all solutions. Remember that that's plus 2 pi k, unless I have something in front of the angle, and also tangent and cotangent, I can cut that in half and do half the answers. But to work through this, I'm going to start it the same way that I did before. I'm going to replace the tangent with a variable that I can solve for more easily. 2x plus 1 equals 2 plus x squared. I'll get everything on one side. So that's x squared minus 2x plus 1. And then I'll go ahead and factor. Do the snowflake method, whatever you need to do. I feel like I've seen this one or a similar one to this before. I'm figuring out what two numbers multiply to be positive 1, add to be negative 2. It's negative 1 and negative 1. So x is 1 and x is 1. I don't have to write both of those. When is the tangent 1? So the tangent is 1 when theta equals pi over 4, and when theta equals 5 pi over 4. Pi over 4 family in the first and the third quadrant, plus 2 pi k, plus 2 pi k, where k is an element of the integers. That's one possible answer. Or I could just write theta equals pi over 4 plus pi k, where k is an element of the integers, because the tangent, remember, repeats itself in half the time, and so we could take a shortcut on that one. So again, same concept, replacing the trig function with a variable, and then working my way through and solving. Got 2 left. This would be a great time for you if you wanted to pause the video and see how you do, or come back and revisit, or kind of turn down the volume and see how you do. But I've got sine here. I'm going to go through and replace my sine with y. So 2 times the square root of 3y squared plus 3y plus y squared equals y squared. And so my y squareds are actually going to cancel each other out. I'm going to have 2 times the square root of 3y squared plus 3y equals 0. This is one of those where I can factor out a common factor. I can factor out y. That leaves me with 2 times the square root of 3y plus 3 equals 0. So when y is 0 and 2 times the square root of 3y plus 3 is 0, I'll solve that. 2 times the square root of 3y equals negative 3. Divide by the 2, so that's y equals negative 3 divided by 2 times the square root of 3. I'm going to rationalize the denominator, multiply the top and the bottom by the square root of 3. So this is negative 3 times the square root of 3 over 6, because that would be 3 times 2, or negative square root of 3 over 2. This sort of felt like it was leaning its way towards this because I saw the square root of 3 and was figuring that that's what that was going to end up looking like, but we did have to do a little bit of work to get there, some simplifying. So I'm finding out when the sine is 0 and when the sine is negative square root of 3 over 2. Oh, this, remember we saw earlier, that's at 0 pi, and then again at pi. And so I'll add the 2 pi k onto that because it's all solutions. And then on the other side, when is sine square root of 3 over 2? That's in the pi over 3 family. When is it negative? In the third and fourth. So theta is also 4 pi over 3. And fourth quadrant would be 5 pi over 3. I'll add the 2 pi k onto both of those to keep moving around the circle, and then I'll say that k is an element of the integers. So I've got a big answer going on there, and that can happen because I had squared, so it sort of doubled my potential for answers. I'm down to one last problem to work through, and that is 0 equals the square root of 2 times sine squared plus sine. I'll again replace that with y's, and it looks like I can factor a y out. And then I'll set both of those factors equal to 0. Oops, sorry, that was 0 equals the square root of 2y plus 1. So negative 1 equals the square root of 2y. Negative 1 over the square root of 2 equals y. Again, I'm going to have to rationalize the denominator on that. Multiply the top and the bottom by the square root of 2. Negative square root of 2 over 2. So when I go set up my final step in the solving, I'm finding out when sine is 0 again, and when the sine is negative square root of 2 over 2. Sine is 0 again at 0 pi, or just 0, and at pi. And I'll add my 2 pi k. And the sine is negative square root of 2 over 2 in the pi over 4 family in the third and fourth quadrant, so that's 5 pi over 4 and 7 pi over 4. And again, I'll add my 2 pi k. Don't forget, k is an element of the integers. And there's my final answer. So remember, you're going to need to work through, when am I solving for just one lap around the unit circle, or when am I solving for all solutions, and what those two things look like. I think the biggest part that's going to cause an issue is our factoring or the solving part of the equation. So please, just like I said, put a variable in there, take your time. You'll start to see patterns and things that show up. I'm sure you've noticed by now that we don't see a whole bunch of different types of answers because we're working with just a limited amount of families. We're working with pi over 3, pi over 4, pi over 6, and then our axes. So a lot of the numbers are going to show up over and over and again. So come with some good questions. You'll work on the review in class, like I said, when we meet again, and then your test will be virtual this chapter. Oh, and don't forget to do the homework for 3 evens or odds. All right, talk to you later.